So we've talked a little bit about Python being our glue, but we've only really used it on Google Colab so far. The truth is that Python can be used just about anywhere, and that includes your own machine. I'm going to right now be using a Windows machine to talk about some of this, but a lot of this just converts right over to a Macintosh if you're using that, or obviously to a Linux machine as well. So I want to talk a little bit in this short section about how you get access to Python and Jupyter using the tools that are available on various platforms. And we'll start with your machine itself. And what I'm going to recommend you use to install Python on your own machine is something called Anaconda. Anaconda is a packaging of Python, and it comes with a whole bunch of the tools already installed that allow you to do data sciencey and social sciencey kinds of things with your computer. So it installs Python on your computer. It has some other pieces as well that are important, including Jupyter, a Jupyter notebook, and a whole bunch of the various modules that we'll be using. There is a version called Miniconda, which is a bit smaller, but frankly, your drives are big enough these days that although this is a big install, I think it runs to something like 3 gigabytes. You'll have room on your machine, and that way you don't have to worry about finding all the pieces, because really it delivers to you most of the things that you'll need to use for the courses in the program and for other things as well. If there's stuff that you need that's newer or that is not included in the 160 or so packages that are part of Anaconda, it's easy enough to use their installer. It's not pip, but a different installer to install those packages. So it's very straightforward, but this gets you started without having to worry about all of that. So there is a professional version, but you really just need the individual edition, the free edition. And if you look down, it's at the very bottom. You'll find, he said, hopefully, you'll find the installers for these for whichever platform you're on. So, for example, for me, it's a 64-bit installer for my computer. Chances are, if you're running Windows, you're running it 64-bit. And so this allows me to install it on my machine. Now, I happen to already have it installed. You'll need to kind of go through the standard installer. I don't think I need to do that for you. Just a quick note that one of the things this does, in addition to, we're doing lots of virtual stuff, right? We've talked about virtual machines. A virtual environment isn't quite the same thing. There will be a link to this on the materials, but you can create virtual environments for your Python programs using something called Conda, which is what Anaconda kind of works as, a manager of sorts. And what a virtual environment is not quite a virtual machine, but it's an environment that separates out one version of Python so that you can kind of install new things for it, if that makes sense, without it interfering with other installs. For now, don't worry too much about this if that doesn't make sense to you. But one of the issues when you're dealing with experimenting with different packages or trying new things is you might have a certain setup, a certain set of packages or a certain set of modules that you want to use, but you don't want to mess with all your other projects. So you can set up a little space that's just for this project. And it's often a best practice when you're using your own machine, especially to set up, or actually when you're using other machines as well, to set up this virtual environment that kind of controls for all of those variables. You can say which version of Python you're using, which tools you're using, all of those little pieces. As we move on, there's actually ways of creating containers that are a little stronger than that, something like a Docker container. And these are ways of really taking even more control. In a Docker container, you might even control things like the operating system and all the little pieces so that you set up the exact environment you want the program to run in. A virtual environment as set up through Conda is a much lighter weight version of this that just kind of says all of the environmental stuff, all of the versions of your Python, all of the versions of the modules you have installed will be specific to this one install. So that's one of the other things that's useful on your own machine, and why Anaconda is more useful than just kind of installing the plain Jane version of Python. Once you have that installed, you'll find on your start list a bunch of things, including something to start Jupyter Labs up straight from the outset. This will come up with a kind of the command lines that are setting up in your shell that are setting up the Python when you start that. But it's nice because you don't have to jump into the shell to start it or anything like that. You just kind of click on a start button the way you always do. In fact, it's a little bit off the screen here, but down below I can just put that on pin that to my bar, and if I want to start one, I can just do that. So I'll just set this aside for the moment. When you do that, it'll open this up in your browser, and you'll see that I have this screen, and if I want, I can start a new Python 3 notebook. It says create a new notebook with Python 3, and I'll kind of run that. And this should look somewhat familiar to you because Jupyter, as I said before, is kind of the basis for what the notebooks in Google Colab look like. So from here, it looks pretty familiar, and I can type something like from math import pi, and then we can print pi, right? We've done that before. So, and as you can see, it's a little more responsive because it's sitting here on my machine. I have 100% control over it. I can load in whatever modules I want. So I've got that here for me. I'm going to shut that down real quick, but go away. I can save that or whatever else, retitle it. I've got this as an untitled IPYNB, the notebook, right? So I've just got a couple of untitled ones here. I've got other ones elsewhere, and I can open those back up if I want to, or rename them however I want to do that. The other thing I could do is, this won't be as important for now, but later on, I can start up a terminal. And this is a Windows PowerShell terminal. So this isn't going to give me, normally I would be able to do, dir, right? But I can also do ls, and it's kind of done some things here that make this usable in various ways. So that's a possibility as well. All right, so I'll close that out as well and close this out completely. And then I'm going to go ahead and it says I can hit a Control-C to stop this kernel completely, but I'm just going to close it out and it'll kind of disappear. So that is Python on my machine. Very straightforward. It used to be a lot harder, but not only Python, but also the notebook setup. As that used to be a lot harder, now it's a lot easier. I've kind of avoided it in the first module just because I didn't want people to have to hassle with installing something before they even got started. But as you can see, it's pretty straightforward to get it installed, and I'm always happy to help out if you're having trouble with that, if you decide to install it on your own machine, which I think probably is a good idea. I'm going to go through a couple of ways you could do it. This is probably not the way you do it, which is I'll put a link to this on the page as well. You can put it on there's now a number of these project boards, right? Arduino and something like this, like a Raspberry Pi. Both of these are ways that you can install Python. For the Pi, it's very, very straightforward. For Arduino, it's a little bit trickier just because Arduino has its own language. A Pi is basically a small single board computer, right? So why would you want to put it on this when you can put it on your laptop? Well, for one thing is you could put this in a little box and build things from it, right? You can put a little shield over and have it connect Wi-Fi via Wi-Fi. And you can use this to build out devices that measure the environment. So if you're producing something, some data, and you have sensors that you can plug into this and find out what the temperature in your kitchen is at any moment and record that, for example. So I'm just setting this here as an example of somewhere else Python can go and be used. I don't know that would be necessarily your ideal place to use Python, right? Unless it's for these kinds of environmental sensing or smart device kinds of pieces. And so there is a course in the program where we talk a little bit more about this when we start to think about data in smart devices and in the environment. For this course, we won't really, but I just want to mention that offhand, that a lot of the tools that we're using here on a desktop or in a high-performance computing environment can also be used on very small systems to do the same kinds of things. Right, so this is for Python. And again, I'll Python for Raspberry Pi and Pi on the Pi or something like that. The last one I want to talk about of these three is setting up on the ASU high performance computing resources, the Agave network. And in some ways, it seems silly for you. This is you getting access to a supercomputer. And you may say, okay, wait, I'm not ready for that. And you're not, probably. If you're taking this course, you're probably not ready to kind of be doing a lot of this work. But very quickly here, you'll be working with large data sets and be working with machine learning. And this is fairly intensive. And there's a bunch of ways you can do that. You can certainly set up, the advantage to having virtual machines, and especially cloud-based virtual machines, is yes, you can go to AWS, and we'll talk a little bit about that later on, or Google Cloud, or Azure, or any of a number of now cloud services that are available online. And frankly, most of them provide access for free to start with, at least. Some period of time you can have access to some level of those cloud services for free, and then the first one's free, and then they have their hooks into you. So you have this ability. This is one of the reasons you don't need to buy a fancy computer, is you have this ability to rent 1,000 computers for an hour, right? Like, you have the flexibility of being able to use these cloud services on the commercial side if you want to kind of run things. So for example, later on in the semester, we'll be talking a little bit about Selenium and doing headless Chrome crawling and scraping online. And you could set up, 1,000 computers out there surfing the web for you, but you rent it, and then once you're done, they disappear. And so you can do that on that front. Or if you're crunching large sets of data, you can also have them distribute your problem to a large number of computers and have them all work on it. That's going to be expensive if you're using something like AWS for a very large project, especially, or the Google Cloud for a very large project. But because you're a university student, you do have access to the research computing at ASU. And so this is a good time to kind of talk a little bit about how you get there easily. And frankly, this is tricky stuff, but they've made it really much easier for you to gain access. The first thing you need to do is make sure that you have an account on the cluster. And I don't know how this works necessarily for you. Some of you may already be set up with these accounts, but if not, there's a link here to a request, which you're going to get to see me log in here a number of times because I'm doing this not from campus, just like you probably are not doing it from campus. And so it requires me to sit here and do the Duo logins, at least for now, for the purposes of this video. And so it's going to ask me to log in. I'm going to go back to here. It's going to successfully log me in, and then it's going to take me to this form. Chances maybe it will take me to this form. So you may need to fill out this form and tell them that you're working with faculty, whoever the instructor in this course is, either me or another instructor, and you'll see it'll ask for some information about who you are. It probably will do what it just did here and populate some of this, and then you'll need to tell them that you're a student and that you're requesting access from the faculty member. And you're fine, since I direct the program right now. You can put in my name, or you can put in whoever the instructor in the program's name is. Once you have that account, you'll need to get access to the network. And pretty much everything you do, that one was maybe an exception here, but pretty much anything you do on the cluster, they're going to ask you to be connected to the campus via a VPN, a virtual private network. Let's take a second. We have all these virtual things, right? We've talked about a virtual environment in this one. We've before talked about virtual machines. But this is a VPN, or a virtual private network, you may have actually been exposed to before if you're interested either for security reasons, right? That you don't want necessarily to have your stuff stolen from you when you're traveling or something like that. So if you work for a company, for example, that has a VPN, they may require you to log into your VPN when you're in a hotel so that people can't spy on your email or whatever. So you may know about it for that reason. You may know about it because you want to watch Sherlock on BBC before it's available in the US, and people have geo-blocked areas of the world. So you may have used a VPN to pretend that you are in Europe and get onto Netflix there or something like that. Yeah, I'm not asking, but that may be why you've been exposed to a VPN. What a VPN does is it basically makes you virtually part of another network. So when I connect to the ASU VPN and then I use my browser, well, depending on how I do it, but if I connect through the VPN and all my connections are through that VPN and I go to my browser, I can then look somewhere else and to anyone else on the web, it looks like I'm actually coming from ASU. I am virtually part of that network. I'm virtually right there. Okay, so there's lots of VPN services. As an ASU student, you have access to the ASU VPN. This is convenient for other reasons too. For example, if you're accessing the library, it's much faster that way to get access to things that are secured and part of the library. There's other reasons, and again, for security reasons, it's useful to be connected through the ASU VPN. So to do that, you'll need to get the client from Cisco, the AnyConnect client. Again, I'll put this, or you can see it right there, but I'll put this connection, this link in the on the page, so you can link to it. And so you'll need to download that client and install it. When you install it, you'll be able to start it up, and here I can bring this down. Well, if you can squint enough, you'll see that this is the mobility client, and it's going to ask me if I'm ready to connect to the VPN. This is the address that you connect to. You'll only have to enter this once, if you have to enter it at all, but I think you do. This SSL vpn.asu.edu/2fa. So this will, if I hit connect on this, it will try to sign me in. And again, you get to see me sign in multiple times. You'll use your ASU ID and your ASU password. And then here, there are actually a number of ways you can do it. You can, through Duo, you can do a Duo passcode. I've had trouble with that. It seems to not like that. So I've just typed PUSH, push. And so once again, I'm going to hit OK. Nothing's going to happen. Actually, it's going to complain. So I get a little thing there, and now I have to go back to my phone. You get to watch me do this. I should probably do like a speed up on this and approve. Now it's actually going through. So the Duo, that's the way that works best for me. I've tried doing it through the codes, and it doesn't seem to be happy if I do it that way. So now I am sort of connected back up through the VPN, and I'm actually connected to ASU's campus through the VPN. The next piece I need to do is go to login.rc.asu.edu. And if I go there, it may ask you, or it may ask me for a user and password again. Like there's this, you keep going through this gateway. In this case, I'm already logged in, but you'll get this page. Now this page gets us access to high performance computing clusters at ASU. And again, they've made it much easier for us there's a number of ways we could do this, but by going to interactive apps, you'll see that there's a bunch of things here, including a Jupyter Notebook. So you can use these GUIs to access MATLAB and some of these other technologies as well, but we're going to be using Jupyter in the course, as we have so far. And if we go here, for now, you don't need to, this is all scary, but you don't need to worry too much about this. This is asking for whether you need particular modules, and there may be at some point you do, how many cores you need. This is kind of how many of these many computers you're actually going to be using, how much time you're going to be using it. And so this is saying I'm going to use it for 0 days and 1 hour. And so this is kind of giving it a request. I want to use the cluster for this amount of time. And then when we start it up, it's going to start up in my home directory. I hit launch. And what it's going to do is it's going to put me up on the board and make a request. It says that it's requested this kind of, hey, raising my hand, I'd like access to one of the computer. Most people would be asking for lots of computers, many of the nodes on this cluster. As it is, I really only need one CPU. And so I'm making a request for that. Now, what do I get it? I just got it. So you may end up waiting longer than this. It depends on who else is asking for that at the same time. So now I can connect to Jupyter. It's going to open up a new browser. And again, this looks, well, it doesn't look like anything because you haven't seen these before. But if I can click on what kind of notebook I want, there's a number of notebooks that are set up here, TensorFlow and lots of PyTorch and lots of kinds of pieces that already have a bunch of modules ready for you to use. All of these are the kinds of modules that you will be talking about, if not in this class, then in later classes when you're talking more about machine learning. But for now, I want to note a couple of things here. For now, we're going to use a notebook, which is a Python 3 basic notebook. So here, I can still do what I was doing before. Oops, from math import py print hello. And maybe we could do also a pi, print pi, right? So this is the same sort of thing. Here are my notebooks over here. This is, remember that Jupyter is much more widely used. It's used on a whole bunch of different systems. We just used it on our own home system. This is Jupyter running on a supercomputer, on the high performance computing infrastructure at ASU. And so you could actually be asking for a lot more from this system. It's probably overkill for some of the things we'll be doing initially, but you have this way you've managed to get access to it. The other thing I'm going to do real quick is go ahead and close out my Jupyter session. Oops, we're going to reconnect. I didn't mean to do that. So it's still running, so I can connect back up. This is the kernel that I was using before. There are other things we could do with this, including going to the console. I'm not going to do that for now, but as we go forward, I can go and kind of run a shell through this. There are other ways to get to the shell. We can use SSH or secure shell to actually get access to that. That may be one reason you would use PuTTY, which I'd mentioned before. But you can also get to it kind of backwards through the Jupyter session and kind of open up a Python shell session as well at the console instead. All right, so that gives you three. This is kind of like again, we're back to the cooking show metaphor. That's Python three ways. But this gives you some options as to how you might want to engage moving forward. You could still use Colab, at least to the extent that it's useful to you. But certainly as you move forward, you're going to find that you have a need for using some things that stick around longer. That is having something you can save and keep and have it be consistent and have access. Or it may start to get bigger, big enough that you need to use the resources of either your own machine for smaller things or the high performance computing clusters at ASU. All right, great.